I continue with our lesson today, so you can refer to page 56, 57 and 58. So this topic is about 2.5, electrical energy and power. So before we continue, let's look at the definition for electrical energy and power. So what is electrical energy? Under chapter 2 form 4, we have discussed about energy. I hope you still remember. What is definition for energy? Energy is ability of doing work, meaning energy transferred is equivalent to work done. So now the power, what is definition for power? Power is rate of energy transferred or rate of doing work. Okay, rate of doing work. Okay, so under this topic, we want to derive formula for electrical energy and power. Before that, I hope you're familiar with all these symbols. E, V, I, Q, R and T. E is electrical energy, V is voltage or potential difference, I is current, Q is quantity of charge, R is resistance, and T is time taken. Okay, let's look at the first one, the first symbol. Electrical energy, if you still remember, it comes from this formula. Potential difference V equals to E divided by Q. Okay, so meaning we can get E equals to VQ. Okay, the second one, voltage or potential difference. We produce this formula under topic of Ohm's law. You get V equals IR. Current, we define as rate of charge flow, meaning quantity of charge divided by time. And then the Q, from the same formula, we get Q equals to IT. R, resistance, from here we get R equals to V divided by I. And then T is time taken. So meaning if you know all these symbols and you know all the formula that we've discussed before, so we can derive formula for electrical energy. Okay, the first formula that we can produce, formula. Okay, the first one. So we can take this one as the first one. So E equals to VQ. Right? Okay, now the second one we get by substitution of another formula. For example, if you substitute V equals to IR, you will get E equals IRQ, meaning the V substitute with IR. Okay, the third one, the third formula, from the same formula, E equals to the Q substitute with IT. From here, I equals to Q divided by T. So meaning Q equals IT. So substitute here. So we get VIT. Okay. Okay, the fourth one. If you substitute here IT, so you will get I R times IT, meaning you will get E equals to I square RT. And then this factor I square R, we use the second formula from here, V equals to IR, square both sides of the formula, so you will get V square equals to I square R square. Or we can say I square R is equivalent to V square over RT. Okay, And then the last one come from the formula of power. Actually, the power is rate of doing work or rate of energy transferred. So P, power, equivalent to E divided by T, meaning from here we get E equals to PT. So we have 6 formulas altogether. So all these formula can be used to solve calculation problems. Depends on the information given. So you can choose which one is suitable for you all to solve the problems. So this one is electrical energy. So electrical energy is defined as ability of the electric current to do work, because we refer to electrical energy. Electrical energy is supplied by a power source like battery or any power supply. So once the current flow, electrical energy will be converted to work done or transferred to other form of energy. Okay, very simple example. If you turn on the switch to turn on a lamp or a bulb, electrical energy will be transferred or changed to another type of energy, such as light energy and heat energy, meaning there is work done to overcome resistance of the lamp that cause electrical energy to be converted to light energy and heat energy. That one is electrical energy. How about power? The same thing we have discussed in chapter 2 form 4. Power is rate of energy transferred. Okay, there is a formula. Power equals E divided by T. So meaning rate of energy transferred or rate of work done. So from this formula, actually we can produce another formula for power by using the formula of electrical energy. From here we have 5 electrical energy. If we substitute into this formula of power, then we also can get another 5 formulas for power. Okay, just divide by T. So we get formula for power. Okay, maybe we can list down all the formula. Okay, I write down here. Power, we use the symbol P. Rate of doing work or rate of energy transfer. So generally we have this formula. Rate of energy transfer, meaning E divided by T. To produce the second formula, we can go to the electrical energy formulas here. Right, the first one, E equals VQ. So meaning we can get P equals to VQ divided by T. Okay, Q divided by T is I. So meaning we can get P equals to VI. Okay, if we substitute the second one, divide by T, meaning IRQ divided by T. Okay, this one we can get later for this one. Okay, so this one is VQ divided by T. The third one is P equals IRQ divided by T. Number 4. So we have VIT divided by T. Divide by T, then the T can be cancelled, meaning we get P equals VI. Okay. Then number 5, I square RT divided by T, meaning we get P equals to I square R. And number 6, P equals V square over RT divided by T. Then meaning V square over R. So actually there's no problem. If we know the basic formula for the power, then only we can produce another formula. So it just give you the idea how we get the formula for power. So actually it's by substitution of the formula, electrical energy formulas, then we get formula for power. Okay, so it depends on the situation or the question given. So you can list out all the information, so you can go and find which formula is the most suitable to be used to solve the problems. Okay, so that one is about formula. So electrical energy and power, the uh, the application of electrical energy and power in our everyday lives is about our electric bill. If you have electric bill, so you can use the bill, you can check how they calculate the total consume of energy and our total cost of consumption. Okay, we're still under the same topic, but now like we want to discuss one of the application, cost of electrical energy consumed. In our country, we use the unit of kilowatt hour. 1 unit of electrical energy, 1 unit of electrical energy is equivalent to 1 kilowatt hour. So normally in your bill, it will state how many units consumed in 1 month. Then by the number of unit consumed, that is the unit kilowatt hour, then we can calculate the cost of electrical energy consumed. The formula that we use, because of this one is electrical energy, so we use the formula E equals to PT. Okay. If you look carefully, this 1 kilowatt actually is power. Hour is time. So in order for you all to calculate number of unit of electrical energy, the power must be in the unit of kilowatt and the time taken must be hour. Then only we can calculate in unit of kilowatt hour. So we don't use joule to calculate number of units. Okay. One example. So let's say we have a kettle. The power rating 240 volt, 1000 watt. Normally all electrical appliances will have this level. Okay, so they will call it power rating. What is meant by this level? This means when you connect the kettle to power supply of 240 volt, it will consume 1000 joule of energy in 1 second. Meaning the higher the power, the more the electrical energy consumed in 1 second. So let's say used for 30 minutes. So what is the cost? Okay. So you want to calculate number of unit. So we use the formula E equals to PT. Remember, 1 unit of electrical energy is 1 kilowatt hour. The power must be kilowatt the time must be hour. So this one given is watt. 1000 watt meaning is 1 kilowatt. So it's 1 kilowatt. And the time taken, 30 minutes, convert to hour. 30 divided by 60. So meaning we get 0.5 kilowatt hour. Electrical tariff, it depends on the country. So we have in Malaysia, let's say we have the electrical tariff for the first 100 unit or the first 200 unit is 21.8 cent or 0.218 ringgit. So meaning we can calculate the cost. So cost is number of units multiply cost for 1 unit. Okay, so we get the cost of consumption for this for this kettle. Cost of consumption. Okay, so the cost of consumption is equivalent to number of unit 0.5 multiply the electrical tariff. So let's say given 1 unit is 0.218 ringgit. Then we multiply, so we get 0.109 ringgit. So it's ringgit RM 1, RM is 0.109, or meaning only 10.9 cent. Okay, so meaning 10.9 cent if we use kettle for 30 minutes. So this is cost of consumption. But in our house we have so many electrical appliances, so we need to total up everything. Our TV, how many TV we use, how many hours we use per day. If we have aircon, air conditioner, then how many aircon we have, and we use for how many hours, what is the power, then we can calculate all. What you do, you must total up everything. The fan, the fridge, the air conditioner, whatever, the aircon and all that must total up. Then you find the total unit, then multiply with electrical tariff. Then you get cost of energy consumption. Okay, so you can go and do some of the calculation problem regarding this one. And this one, if you discuss about cost, this one will come out in paper 2 or so, a SEPA. Okay. Okay, the last part of this topic we'll discuss about efficiency of electrical appliance. Efficiency of electrical appliances. For example, we have a lamp. It gets electrical energy from the power supply. So transferred to the lamp. Okay, so this one we call it input energy. What happened? There is work done to overcome resistance of the lamp. So electrical energy will be transferred to other form of energy. There are two forms of energy that we get here: light and heat. So these two types of energy, we call it output energy. we use lamp for its light. So this light is useful energy. We don't want the heat, so this one is wasted energy. Okay, so what is efficiency of the lamp? Efficiency is percentage of useful energy produced by the lamp compared to the electrical energy supplied. So we have the formula like, energy output, useful energy output, divided by energy input, multiply 100%. Or we can use the output power divided by the input power times 100%. How many percent of the electrical energy that supplied that change to useful energy? So in this case, the useful energy is light, a lamp. Okay. Let's say electrical energy supply is 50 joule. The lamp will receive input energy of 50 joule. What happened? The useful energy, let's say just about 40 joule. Another 10 joule become heat energy. So what is efficiency of this lamp? So we use the formula useful energy output. So we get 40 joule divided by input energy 50, then multiply 100%. So we get equals to 80%, meaning efficiency of the lamp is 80%. Ability to convert input energy to useful energy is 80%. Okay, the perfect electrical appliance, it will produce 100% of efficiency. That one is we cannot really get in our, I think in our life also we cannot get that perfect 100%. There's always a small amount of wasted energy. So we get like 99% is the best one. Okay, so this one is 80%, meaning 80% of the input energy will be converted to useful energy. Then we can compare which lamp is better. So if we have two lamps, then we can calculate the efficiency by comparing the efficiency. Which one is more efficient? That one is better. Okay, so I think that's all for our lesson today. So we have finished chapter 2 electric. So you can try formula exercises on page 58 onwards, okay, in order for you all to understand better this topic.